So we're jamming out to some psychedelic trance music. So my thought process was to create a door with a recessed hole for a magnet to go in. Little magnets like this. Anyways, the magnet is so right now this is 2 millimeters from here to here, and I ultimately need to recess the whole 3 millimeters. So this is actually 3 millimeters right here for a total of 5 from here to here. So basically, this hole is going to be recessed exactly equal to this raised piece here, which will be inside the door, underside, so you won't see this raised lip. I went with 2 millimeter thickness for the door just to give some rigidity to it. So the next thing would be to. This song is not good. The next thing to do would be to create some sort of so this is 15 millimeters, I believe, if I remember right, from side to side. Maybe like a 5 millimeter flap right here in the middle, and that would slide into a hole. Um, Trying to think of how to describe this, but imagine like on the receiving end, the hinge side of the box, the structure itself, there'd be a 5 millimeter slit, and then this 5 millimeter flap would fit into the slit, and then so it'd be like it would slide into the slit hole, then press down and magnetize closed. If that makes sense. So up to this point, I've known how to do everything pretty easily, but now I don't know what to do. So here's all the components. Let me start naming stuff. Door pad. What is this? Not sure what this is. So how this works is everything's in 2D. So for example, this door here, this sketch, it's just a 2D rectangle that is 20 millimeters at the bottom and 40 long. Once you create the 2D sketch, you then add a pad to it, which is this thing here. And a pad just makes it from 2D to 3D. So if I change the pads, it has 2 millimeters, but if I change it to say 5, see this part right here. If I were to remove the pad, it would just become a 2D object again. I need to create a triangle on this side right here. So you click the side you want to draw on, and create a sketch. I mean, I could just make. I could just make a rectangle. Mm, 10 by 1. I guess 2 millimeters. 2 millimeters is not very big. Alright, well, I think what I'm gonna do is just make a nice rectangle that's not very big. We'll say point 0.8, and it's 10 millimeters, but this is 20. So this side needs to be. So 10, 20 minus the 10 gives me a remainder of 10, and then half of the 10. So how you do this is, this is 10, this is 20. So the middle point of this needs to be 15. Uh, so minus 5, so this makes this uh, 5, which it is. Redundant. Okay. Oh, I see. So if I want this to be. Shit. I want to make this point 0.8. I messed that up. Damn it. Oh, I want to make this flushed with the bottom. This needs to be 1.2. Okay. And then I'll add this to sketch. Say 1 millimeter? What's that look like? Or 5? So the theory would be to print this door, you're actually looking at the inside the door, the underside. And so like what the user would see from the outside is this. But what the main device, the like brick itself, will have a slit that this will recess into. So it'll actually sit flush sit flush along this wall right here, so they won't actually see this tab. Cool. I mean, some things to fancy this up would be I could round corners. You don't really see any of this, but I would still make it look pretty. But to round corners, you can just click on a corner and click this feature and be like 30 millimeters. See, it rounds it. I don't want to do that though. There's door hinge flange sketch. This is pad. And so honestly, I would test print this at this point and see what it's like. I don't know if my printer's on though. Hang on, 1 second. Okay, it's turning on. Hmm. My screen just went black. There we go. Alright, so I'm gonna save this. And then you have to export the so it's saving it as like a CAD file. Looks like this FC file. I don't know. You gotta export it as STL file, which is a picture freedom. You can call this V1. So now I have this file, and that's the file you drag into Bamboo Studios. So this is the app used for the printer. So here's the printer, all the crap going on. Into a live camera view of the prints. Anyways, you just drag the file over here. And I actually oriented it so I don't need any support stuff. I'll show you what I mean by that. So if you're printing like things that have overhangs, the printer prints from bottom up. And so if you have an overhang at halfway through the print, it can't just print into free space suspended in the air. So it intelligently somehow creates creates supports. It's like in this design, technically these holes are freestanding, like suspended in midair, as it tries to print. Let me rotate. As it tries to print like this first line, it's hard because it's all black, but as it tries to print this first line of this overhang, so it's dead space. Just putting this straight line across it would collapse. So you have to turn on supports. It just intelligently creates them. I don't know how it does it. You press slice and it creates all this stuff. So now you'll see it creates these like little hollow tree things throughout the whole print magically for you, anywhere it feels it needs support. And it doesn't cost much in plastic. It's very hollow and just one line of plastic. Anyways, the design, it's better to not have to rely on supports. So, like on my new design here, when I'm printing this door, had I flipped this object 180 degrees, where this little flange thing was up here, and I flipped it 180, oh, Jesus Louise. If we flip it 180 where this little flange was up top, then it would have to create a support to reach up to it. But because everything is built from logically from the bottom up, it doesn't need any supports. Let's see here. I like to print that G. I don't need supports. All the other basic settings are fine. You hit slice, it like calculates how much filament it's going to take and how long. So 2 grams. Spool is 1,000 grams, so it's, I don't know what that is as a percentage. 2 grams out of 1,000, not very much. False pennies, 5 cents, it says. And model print time is 5 minutes, prepare time is 7, so it does like a bed level every time. Total time 12. Or you can turn off bed leveling, which I usually do because I don't move it very often. So this will only take about 5 minutes to print. Alright, so that clip you saw a second ago is it's basically 25 frames of it being created slowed down to 25%. It's a fast print, so it's not a very good display of it being built. So here's the final piece. Got a caliper. It's 20 wide. Yep. It's 40 long. Yep. So that little recessed hole, I only made it 1 millimeter or something like that. Because the magnet is 3 millimeters tall and I want to be able to get it back out. But so see, just fits right in there. You got your little tab that it built on. So like the end user just sees the face plate. Yeah. Oop. So the tolerance on the hole I could probably take off 0.1 millimeter so that the magnet sits in there more snugly as opposed to just falling out. Either way, I'm gonna super glue it in, so it doesn't really matter. Yeah. So is this door big enough for the final prototype? I don't know. I mean, a brick is I don't have one on me, but the bricks I got are I think it was yeah, it's 58 millimeters long, the brick itself. So I probably could make this a little bit bigger so that you could actually like get your fingers in the door to change out the cord. Because the whole purpose for this door is to make it so that you can change out the cord inside of the brick mechanism. This is not the brick that I'm building for this door concept, but yeah, so kind of cool. All right, well, next I think I want to build just a mock prototype square that this door would fit into. So in my head, what I'm thinking is uh, I had something on my desk. Here we go. So here's just like a rectangle or well square. I'm thinking about building a tall square that this door would fit into. It'd be like put in and then snap down. And so one side of the so let me give you a bigger object. One side of the rectangle is going to be I'll use this big wallet. I'll use my wallet. So imagine this is hollowed out and it has just walls. Uh, let's use this. So imagine this is the thing. It's hollowed out. One side is going to have a slit in the sidewall that the tab goes into. and then the other side is gonna have a little lip that comes out, like a little square lip that comes out, and it's gonna have another recessed hole in that square lip. So the kind of the concept of the magnet hole, but towards the inside, so it'll actually need supports to hold it up. And so when it clamps down, it'll snap into that magnet slot. So this one's probably gonna take me like a half an hour to build if I had to guess. I'll build them as two different part files. So this file is saved. I'm gonna reopen FreeCAD. You can now see it from scratch. So here's a basic starting from scratch, nothing. All right, so let's see here. I need some notes. This piece is 40 millimeters long. And 20 millimeters high. 20 millimeters high. Plus 1.5 millimeter flange. And you can't create things to be exactly because of walls, so you gotta take off about half a mil. Which means the inner wall door, the box, needs to be inner 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 length needs to be 41. Tolerance of 0.5 millimeter on either side. Um, oh, but I have. Oops, good catch, Micah. Inner height equals 21. Tolerance of 0.5 millimeter on either side. So I need to modify this. Let's say 41 gives me the tolerance for the walls. I need to account for 1.5. I think I'll just add 1.5. So plus 1.5 equals 2.5 total. Notes for my box. Slit needs to be flush with one end. Doesn't matter which end because it's just a prototype. It'd be like the top or bottom of the square rectangle. Alright, so that's just my rough notes to start off with. So first thing I need is this. I want to build this first. So I need a centered rectangle. Oops. It is 22.5 by 21. That's the inside of my square. Now I need to create an outer square because it's going to be a 3D object. So let's just add 2 millimeter walls. 23 by 44.5. Oops, shit, wrong way. The 44.5 by 23. That gives me 2 millimeter walls. Is that thick enough? It's the same thickness as this door. I'm gonna say no because My tab is 1.5 millimeters, and it's going to be recessed into two millimeter door. So that means there's no wall where the tab goes in. So actually, what I'm going to do is not make that a centered rectangle and just make a rectangle. I'm going to make one side bigger. One wall is going to be 4 millimeters. Or we'll say three. Uh, we'll give it 2 millimeters. So 2 plus 1.5 is 3.5. So I need to do so 20 is the inner, and then I want 2 millimeters on every side, which makes it 23. Well, I already know this one, so 44.5 by. Oh, hang on. If the inner is 20, it needs to be 21 to account for tolerance. That's 0.5 either side. Tolerance. Okay, so that works. So 23 millimeters. There should be more. This actually needs to be. So I need inner box. We're thinking out loud and time with you, so inner box. Inner length equals. So it's 42.5, and then I need plus 2, which is 46.5. But I need plus 1.5 for 4. But the 1.5 needs to be staggered to one side. So the side with recess port will be how thick? 1.5 to 4 millimeters. And the other side should be equals, so 49. And 49 minus 41 is, or 42.5. 49 minus 42.5 is 6.5. Yeah. So 6.5 minus this 4 leaves 2, which is exactly what I wanted. Opposing side should fall to 2 millimeters. Okay. Inner height equals 4, so 21 plus 4, 25, 2 plus 2 for each side. So there could be some up here too. Okay. I wonder if you can see this still. So inner. Okay. Other box should be long is 49 by 5. Do this. Okay. Now we gotta establish these dimensions. So I'm gonna do the left side is the 4 millimeters. So my little door flange should be on that side. This side should measure 2.5. I think it should be 4.5 on the other side. 4.5 would give me, no, because 4.5 minus the door of 1.5 gives me a remainder of 3 on the sidewall of 2. That's all into zero point 0.5. So it could be 4. And then this should be 2. It's 2.5. Well, I could just make this 48.5. In the grand scheme of things, it wouldn't really matter, I guess. But I do want to learn to be technical about this. Let me change this. Oh, oops, that's why. So it should just be plus 1. It should be 40 plus 1 equals 41. There we go, that's why. I messed it up. Yeah, I messed out. I messed that up. You might have already seen that in the video, so whatever. So 41. So then I need 41 plus 4. I'm reverse engineering this so I know I'm doing it right. Plus 4, which is my sidewalls, is 45. Then I need 1.5. Fuck! Plus 1. Very counted for tolerances. So 45. Then plus 36.5. Why is my inner box 42.5? Oh, I messed it up earlier. Should be 41. So then this is going to be way bigger right now. Maybe like close to 4. Yeah, 3.5. So this should be 46.5. And then this should be 2. But I think it's 1.5. Yeah, 1.5. Oh, 'cause this should be 3.5. Yep, there we go. All right, so then I just need to do north to south here. So this should be 2, which means this should be 2. Yep. Okay, perfect. So this would be primary, I don't know, box sketch. We're gonna pad this bad boy. That's pretty tall. This is 4 it'd be half the height of this. Yeah, that's okay. We'll keep it at 10. Okay, cool. I just thought of something. So if I recess a hole for this to be flush, like see on the top, it would rest on top.
Feel the rhythm, feel the flow, feel the path to the unknown.
What I should have done is put that hinge, actually, the little flap on the bottom so that it can actually sit down in there. So what's going to happen is I'm going to build this just for the sake of this video where the slit is just below the top right here.
Begins with you. Be real and feel.
Um, Damn, I forgot how big the flange was. It was 10 by, we'll do 2. No, it was 1 millimeter tall. So we'll do, but I hate when it bugs out. It's 1 millimeter tall, so we'll do like 1.5. Okay. And then we need it centered. That's 21 inches. So what's half of 21 is 10.5. Well, first let's do this. We'll put it just a millimeter from the top. Whoa. And then we'll put this. Oh, math, my head, it's getting late. There's probably ways to like just auto center this shit, but I don't know how to do it. So, it's 21. minus 10 is 11. 11 is 5.5. Should be center. There we go. Okay, close. Now we need to reverse this. I'm gonna go 1.5. Boom. Cool.
Feel the rhythm, feel the flow,
Oh.
feel the path to the unknown.
Now we need to create this recessed lip for this thing. So, where the magnet goes.
On the dance floor we find
So the
freedom,
square was 8 millimeters.
we
Took some
are
notes.
one. Lost in rhythm, we're moving freely.
Square
Feel the
was 8
music
millimeter by 8 millimeters.
on the dance floor we find freedom.
Circle diameter was 6.4 millimeters. And total height is 5 millimeters. That's like the height from base plate to the bottom of the opening for the magnet. But now I need to account for this 1 millimeter drop here. I want it to at least be level. It's not going to be flush across the top. It's going to be 1 millimeter recessed down into this box. But I at least want it to be level. I would have to. No, the way to fix this is just to. Well, I should just fix it. Yeah, I'm just gonna fix it. I'm gonna reprint the other part so that this actually sits flush. Alright, so that said, I need to create this platform for the magnet, which on this side, I need an 8 by 8 square. Well, I don't need an 8 by, I just need an 8 by. The pad's gonna be 8. So it needs to be. The magnet's 3 millimeters tall. Let's just make it 8 long by 5 tall. Okay. And to center this shit. So it's 8. It's 21. So 21 minus 8 divided by 2. I think it already is center. 21 minus 8 is I don't want to mess things up. That's 8 divided by 2 is 6.5. Yeah, that's already good. And then I need from the top. In theory, the magnet sits flush. So we flush. So that needs to be down 5.5. Let's start with 5. Oh shit, I need the pad to be bigger. There we go. The dimensions of this square compared to the height of the whole object was good. So 5 millimeters would be the exact length from here to here. I need to create a tolerance of say 0.5. Okay. And then we gotta pad this sketch. Okay. And then we gotta draw a circle on here. That's 6.4. And you do 8 minus 6.4 divided by 2 is 0.8 from either side. Oops. This should be 0.8, and it is. This should be 0.8. Oh, hmm. Let's try from this. Ah, I think that's like 8 as opposed to 0.8. That's probably why. There we go. Cool. Okay, and then I need to hold this out. Technically it should be 3, but I'm gonna do 2. I'll remove the magnet. I'm feeling pretty good about this. Not bad. I like to name my stuff, so sorry, but you're gonna watch me do that for a minute. This primary. What is this? This is um box or magnet sketch. Box or magnet pad. Hole or magnet. Um, Pocket. Sketch. Slit or flap sketch. Pocket. Okay. I actually want to make this wall a little beefier and this flap a little bit beefier. I feel like it's just not good. Which means I'll make another millimeter. So let's make this 47.5. And we'll make this 4.5. Which gives me about, I can make the flap 2 or 2.5. I want the tolerance to be tight. It's only 1.5 right now. Let's do 48 and 5. Keep these numbers moving around. Okay, so then that means we need to make the slit for the flap, the pocket deeper. Let's say 2.5. Well, technically we could go all the way to 3.5. So 2 millimeter sidewall. Let's keep it here. Wait, want to look at something? What's this wall density? 5? So this needs to be 3. So the slit is 3 millimeters deep, but the wall is 5. This is 5. The slit takes up 3 millimeters of that, which gives me a 2 millimeter flap, which is only 0.5 bigger. I don't want to double it. It needs to be a 3 inch recess. When I say inch, I mean centimeter. It is 3. Okay, cool. All right, this is good. So at least try it. Last one was door prototype. So door base prototype. I don't know. And what we'll do is we'll get this running, and then we'll go back and fix the other one. So there's definitely supports needed. Or I should. There's even gonna be little supports in there. Got little tools I can use to pull it out. And see there's gonna be supports there. This is Peggy up. Time lapse I can put in the video. So, okay. So that's great. Let's go back to fixing this. So I actually want this to be. Oh, it's a 0.8 inch. It's all right. Just rebuild it. It's 10 millimeters long, and we're doing 0.8 tall. That's centered. One degree of freedom left. So this should be the 1.2. Damn it. Close. Cool. So now the flange is instead of this tool is finicky. Instead of the flange being down here, it's up here to fit down into that slot. So just save and re-export. Oops. It's the same file name. Yep, this one. Cool. So we'll print this. This song is not good. Jeez Louise. So this will come next. And yep, the flange is up top. Does it need supports? It's not saying so. Oh, damn it, I forgot to fix the pad. Gotta be a longer slot. So we wanted it 3 millimeters long. There we go, now it's longer. We're gonna do like, this is all, I mean, I'm learning, so we're gonna do like 2.6. Alright, cool. It's got supports now, as I would expect. Alright, so you just saw the slow-mo of the brick being built. I actually detached it from the printer. There's the, oh no! The support that holds up the little, part that holds the magnet. The support actually just broke right off. I didn't even have to clean it up. But at Harbor Freight, you can buy these like, they're like dentist picks of different sizes. Um, so there's one that's got like a pick that's ultimately inside the little recessed hole in here. There's junk. Although I'm not sure if these picks are good enough or small enough. Shit. There we go. So in a production version of this build, I would want to buy a better pick. So this part's now good. Hold on, I don't like little plastic strands being everywhere. So hold on. Trash can for little plastic stuff. All right, and then we have the new door with the little notch out of it, and it's got a little bit of cleanup right here. This one should just pour it off. Yep. Ah, there's like one strand that's kind of stuck. Oh, I don't like these little plastic pieces being everywhere. Anyways, so let's see how this fits. Cool. I will say that I built in too much tolerances. There's like a, I don't know if you can see this. You can probably see around the edges. You can kind of see around the edges. There's gaps all the way around. So I just need to tighten up the tolerances, and that's why I built these little prototypes. Um, and now the magnets, so I got both magnets attached to each other right now. Not gonna glue them in, but yeah, it fits real good. Yeah, probably not gonna see it on camera, but it's very flush in there. And then in theory it would be like very little gap around the side. And then you could use, something to reach down that little gap and pull out. I'm feeling the magnet strength right now. Oh, that's kind of hard to tell because the magnets aren't glued in. Yeah, it's like impossible to tell because the magnets aren't glued in. But yeah, I mean, sure, 2 hours into this from scratch. But yeah, it's really not that hard. I mean, it's staying with no super glue and with loose tolerances, so that's pretty cool. Well, anyways, that's it's a simple little door using some magnets to keep it closed type build. Um, so yeah, hope you enjoyed watching.